Hello dear learners, you are most welcome to our third lesson of fractions. I'm teacher Kato Ivan from WUNNA Educational Services. We are looking at how we compare fractions using the idea of equivalent fractions. So, in our previous lessons, we looked at how we get equivalent fractions, how we reduce a fraction and express it in terms of its lowest terms, and we also looked at how we can express a fraction with a new denominator. In case you missed, please kindly go to our playlist. You find that playlist named O-level fractions. Watch right from the first lesson so that you catch up with us and we move together. Otherwise, at this very moment, let's look at how we compare fractions using the idea of equivalent fractions. Yes, we are told that the idea of equivalent fractions can be used to compare fractions. And we shall be looking at our example 3 on how to look at how fractions are compared by equivalent fractions. So our question is, arrange in order of size, beginning with the smallest the fraction is given. We have 4 fractions, which is 3 over 4, 5 over 8, 7 over 12, 7 over 9. Yes, someone may not be in position to tell which one is bigger, which one is small, and which one should come first and last in our order, whereby we are supposed to rearrange these fractions in order of size, beginning with the smallest. So, how do we determine the smallest that should come first to the next until we get the biggest that should come last, according to our arrangement? Now, this is where we bring in the idea of equivalent fractions. First of all, we shall make sure that we first make all the denominators the same. We shall first make all the denominators the same. That's when we bring in the idea of equivalent fractions. How are we making the denominators the same? We shall look at a factor that can make all these denominators appear the same. So we shall look at that using the idea of the LCM or LCD. So yes, if you look at our denominators, we had the 4, we had 8, 9, 12. So we look at the LCM of these denominators. Yes, I don't know how best you can get the LCM, because in this very example we use the powers of the denominators. We expressed the denominators as products of their prime factors, thereby having 4 as 2 squared, 8 as 2 cubed, 12 as 2 squared times 3 power 1 and 9 as 3 squared, whereby if you look at our denominators, they are expressed in the form of 2 and 3. So since they are expressed in forms of 2 and 3, we look at the highest order of 2 and 3 are the ones that we shall multiply to get our LCM. That is to say, the highest order of 2 is 3. 2 power 3 is our highest value or order of 2. So we shall pick that out, and then the highest order of 3 is 3 squared. So we shall take the highest order of 2, which is 2 cubed, times the highest order of 3, which is 3 squared. We multiply 2 cubed times 3 squared. That is how we are getting LCM, though we also have the ladder method, where we shall break down each of these denominators using prime factors until we reduce them to 1. After reducing them to 1, we shall multiply the divisors to get the LCM. So you can use your best method of getting the LCM, but at the end of it, it must give you the same as we have. Alright, so after expressing after obtaining our LCM of the denominators, which is 72, then we are going to express the fractions as equivalent fractions with the same denominator, 72, since it is our LCM of the previous denominators, which were 12, 8, 4, and 9. Those were our previous denominators. We are expressing them by our common lowest multiple, which is 72. So after expressing all the denominators as 72, then we are going to multiply that 72 by our original fractions, and since we have the same denominator, therefore the value will be determined by the numerators, the new numerators we shall be getting. That is to say, we are going to multiply 7 over 12 times 72. Then we multiply 5 over 8 times 72. 3 over 4 times 72. Like that. And the answers we shall be getting after multiplying are the ones that will be obtained as our new numerators. Hope I'm clear. I'm saying that after expressing each of the denominators as 72, then how are we obtaining the numerators? It is very simple. We go to our original fractions. These are our original fractions. We had 3 over 4, 5 over 8, 7 over 12, 7 over 9. Now we shall multiply each of these by the LCM 72. For instance, 3 over 4 times 72 gives us 54. That 54 becomes our numerator over 72. The same applies to this. For instance, 5 over 8 times 72. When you reduce 72 by 8, you get 9. 9 times 5, 45. Now the 45 becomes our new numerator out of 72. The same applies on the other two remaining. So what we are getting after multiplying the numerator, the fraction by our LCM, the answer we get becomes our new numerator out of 72. Hence, obtaining 54 over 72, 45 out of 72, 42 out of 72, and 56 out of 72. And now we shall determine the value of a fraction not by the denominator because they are the same, but by the numerator. So if you look at the numerator, it is 52, the highest, and the fraction with the least numerator has the least value. In this case, the fraction with the least numerator is 50, is the one of 42 over 72. So that one becomes our smallest fraction. And the fraction that gave us this is traced back, which was 7 over 12, because if you remember, if you multiply 7 over 12 times 72, you will get 42. This one gives you 6. 6 times 7 gives us 42. So we are going to trace back the fractions, the original fractions that gave us these numerators, and therefore the one that gave us 42 out of 72, which is 7 over 12, is the smallest, so it comes first. Then followed by the one that gave us 45, which was 5 over 8. Remember, when you multiply 5 over 8 times 72, the 8 reduces 72 to 9. Then 9 times 5 is what gives us 45. So meaning that 45 over 72 was from 5 over 8. And since it is the second smallest, so it appears second. But the original, not this one. Hope I'm clear. Followed by 54 over 72. Now, which fraction gave us 54 over 72? It was 3 over 4. And the last, the biggest, is the one that gave us 56 over 72, which is 7 over 9. So that is how we rearrange or arrange given fractions in a given order. This is ascending order from small to big, but descending is from big to small. We get all the orders following the same procedure. The procedure is simple: getting the LCM of the denominators by your favorite method. After getting the LCM, multiply each of the fractions by the LCM. But the answer you get becomes our numerator, and the LCM becomes our common denominator for all the fractions. And now, when grouping or arranging the fractions, we arrange depending on the numerators. The one with the smallest numerator shows the smallest fraction. The one with the biggest numerator is the biggest fraction, and then we shall arrange accordingly, but not arranging these multiplied fractions. We shall be arranging the original fractions that gave us these equivalent ones. So in other words, these are equivalent fractions to these original fractions. That's why we're using the idea of equivalent fractions in comparing fractions. So that is it. Otherwise, at this moment we have discussed a lot right from our first lesson. So we have some assignment that you are going to try out to test whether you have been with us all along. In case you didn't watch the first two lessons, please kindly go to our playlist, look for O-level fractions, watch right from the first lesson up to where we are, and then attempt these numbers so that you evaluate yourself how much you have achieved in this very learning. Otherwise, for today we shall end with this assignment, which I expect you to work out and then comment with your answers so that we determine whether you have achieved the learning outcomes or not, so that we look for the way forward. Otherwise, I remain Teacher Ivan from WUNNA Educational Services, your teacher of mathematics and physics. We have a lot of videos that we've recorded in the past. Just visit our playlist and go through those videos. You really enjoy the lessons. Otherwise, for now, we are closing our lesson. I hope to see you in our coming lesson. Bye bye.